All right, chapter 9.1, we're continuing with conic sections. Today we're talking about ellipses. Um, we're going to graph ellipse centered at the origin. We're going to write the equation of ellipses in standard form. Graph ellipses not at the center. We're going to skip solving just to keep this simple, I think. Um, Jumping into this, an ellipse or a conic section remember, comes from these things comes from a cone, basically. And if you take a cross section of a cone straight across, you end up with a circle. If you cut it across at a diagonal, you're going to end up with a ellipse. If you cut it across at a steeper angle there, you end up with a parabola, both one facing up, one facing down, right and left. Um, and then lastly, ellipses. Um, Looks like this. And again, they could face any direction you want. So to start with, I need you to probably stop the video and write down the formulas. Notice that those formulas are identical with the exception of two things, right? What's in the denominator, a over b, or a squared and b squared. The larger of the two numbers will be under the x. The larger of the two numbers will be under the x. I'm sorry, I lied. It would be the larger of the two numbers will be the a squared. So if it's an a squared, it's going to be a horizontal. If it's under the y squared, it's going to be a vertical. All right. So graph and locate the foci. Okay, the foci are these points right here. By definition, every point here is going to be the difference of the distances from the foci to those points, and they will always be the same. You can calculate your b squared, your c squared. Um, Notice your c squared is where your foci is located. Okay, so here we go. I know that a is the square root of 36, or 6. I know b is the square root of 9, or 3. I know that c is equal to the square root, based on the formula on the previous page, of a squared minus b squared, 36 minus 9, or square root of 27, which equals 3 root 3. By the way, we know this is going to be a horizontal ellipse because the larger number is under the x squared. Okay, my center of the ellipse is at 0, 0. My distance a goes from 0 to 6 and 0 to negative 6. My b value plus or minus 3. And then my foci are 3 root 3. And the question is, how big is 3 root 3? You can plug that in your calculator, but you know it's going to be a little bit bigger than 5. So that's going to go right about there. Square root of 27 is a little bit bigger than 5. Okay, and then from here, we're going to graph our ellipse and hopefully end up with a beautiful smooth curve. Horizontal ellipse. All right, you'll notice that our formula said that it was a squared over, that's not true, x squared over a squared plus y squared over b squared equals 1. Could have been x squared over b squared plus y squared over a squared. That's fine. But we need to put this in that form. And so the one key factor here is that 144 needs to be a 1. So if I divide that by 144, I'll end up with a whole new equation, or same equation looking differently. And again, if you just simply divide, you end up with two separate fractions. you now know, I mean, this was the answer to the question, but you now know your A value is 4, your B value is 3, your C value is the square root of 16 minus 9, or the square root of 7. All right, problem number 3 asks us to find the standard form of the equation of the ellipse with foci and vertices. Now remember, I should use the terminology, the longer term, the longer vertice is your vertices, the shorter one is your covertice. Your standard form is going to be x squared over a squared plus y squared over b squared equals 1. And I would start simply just by sketching this graph so we can kind of get a visual. I think it's easier to see if you sketch it. I know that the foci are at plus or minus 2. So here and here. I know that the vertices are at plus or minus 3 here and here. What I don't know is what the covertices are, right? So based on what we know, I know that my A value is 3. I don't know my B value. I know my C value is 2. If I plug that into the equation that we gave you, uh, remember C squared equals A squared minus B squared. So 4 equals 9 minus B squared. B squared equals 9 minus 4. B equals the square root of 5. Square root of 5. Square root of 5 is a little bit bigger than 2. We know that, but that's irrelevant. We can now take this information and plug it back in over here. X squared over 9 plus y squared over 5 all equals 1. That is your solution. We know this is a horizontal ellipse. We knew that the previous one was a vertical ellipse. In other words, it's going to be shaped more like this. Okay, so when we move these away from the origin, you're introducing your H's and K's again, and I would stop your video if you need to look at this a little bit longer, but notice that you've got two formulas again, and it's all about the A's and the B's. The H's and the K's stay the same. And again, I think we can figure out what distances are. The distance from the origin, from the center to the foci will be your C value. The distance from the center to the vertex would be your A value. The distance from the center to the covertice is going to be your B value. They give you formulas to try and solve that. This formula here, the C value hasn't changed. All right, so our last example here is asking where is the foci located? And we should also consider graphing this. It does say graph. Okay, so let's start by figuring out what we know. We know the larger number is A, right? So A is equal to square root of 9 or 3. Your B value is the square root of 4 or 2. The C value is going to be the square root of 9 minus 4, or the square root of 5. We've seen that before. We know my center is located at -1, +2. -1, +2 right there. We know this is a horizontal ellipse because the 9 is the bigger value. It's under the x squared. So I'm going to move 3 units, 1, 2, 3 this way, 1, 2, 3 this way, up 2, down 2, there and there. My foci is something a little bit bigger than the square root of 4, right? So a little bit bigger than 2, going to go right about there. 1, 2, right about there are my foci. And then we got our ellipse. Again, draw a beautiful, perfect ellipse if you can. All right, almost perfect, right? All right, so where are the foci located? Let's answer that a little bit better in the sense that this is going to be um, taken from your center and it's going to be moved right or left, right? So my center was -1 plus or minus √5, comma, 2. Um, and you can write those in that form if you want. There's 2 points there.